This is Mr. Anderson, and in this video I will be doing a review of quadratic functions. In this first video we will be recognizing different parts of a parabola, either given the graph or given the equation in vertex or standard forms. Alright, so first, looking at this graph, the vertex is that very lowest point or highest point. If your parabola opens downward like so, right, then your vertex would be up at the highest point, the maximum point for your parabola. So here we see our vertex right there. It is letter C. The next one says slope multiplier, the A value or slope multiplier. So real important for when we are going to be graphing. This A value, when I always go write just one line, when I go write one line from my vertex, what is that distance that it takes me to get back to my parabola? I go one line away. Now I'm not on the parabola. What's that distance that it takes me to get back onto that parabola? In this case, that distance is 1. The letter for this is F. The axis of symmetry. Simply, the axis of symmetry is the line that chops our parabola in half. So this right here, it is drawn with a dashed line because it is not part of our parabola. The parabola is drawn with a solid line because it contains all the points that are solutions for our quadratic equation. All right, so the axis of symmetry, the equation is x equals 3. It is always going to be the same as your x-coordinate for your vertex because it's right on the x equals -3 line. The letter for this one is D. Does this have a maximum or a minimum? This one has a minimum, and you can kind of think of it this way. Our parabola, it goes down to a minimum point, right, and then goes back up. It goes as low as right here and then goes back up forever. Because it goes up forever, it does not have a maximum point. All right, notice if the parabola was flipped upside down, it would go up to a maximum point, the hilltop there, and then go back down forever. All right, so the letter for this one is H right here, because it goes down to as low as -3 on our y scale. There's no more parabola after -3, going below -3. The y-intercept, you probably know that one. It's the intersection with the y-axis, and the letter on this is B. The x-intercept, this one has 2 x-intercepts where it crosses the x-axis, E. X-intercepts are also known as solutions or roots or zeros. Right, and notice that there is 3 different things that can happen with those x-intercepts on our parabola, right? The parabola could just come down and just touch at one spot, right, and have one x-intercept or one solution to that quadratic equation. It could have 2 intersections like ours does, or it could have no intersections like this one over here. right? It does not intersect our x-axis at all, and it means there's no real solutions because there are no x-intercepts. All right, the domain, that's how far left or right our graph goes, and that is the left and right. That is our x values, so A is our domain. The range is the up and down. How far down does our range go? How far up does our range go? Notice that it goes to the left forever and it goes to the right forever for our domain. That's the same for every parabola. However, the range is different. This parabola, it goes down as low as -3 and then stops, right? So all of the y values for our parabola have to be greater than -3, and that's why it is stated that way. Y is greater than -3. The letter for this one, oh, we need to scratch that out. I got 2 letter D's. We're going to call this one letter I. Okay, and finally the end behavior. What does our graph do at the ends? And that's demonstrated by these arrows over here. On the left end, we can see that our graph clearly goes up forever. But notice it also is slanted to the left a little bit. It goes to the left forever as well. And same thing on the right end. It goes up forever, and it also is a little bit slanted to the right there. It does, in fact, go to the right forever. You could also say this as x is decreasing, y is increasing. And as x is increasing, y is again increasing. So the end behavior letter there is G. All right, let's continue on. Here's in vertex form. We have to identify different parts of the parabola. The nice thing about vertex form is it tells us the vertex. What we need to remember so our vertex is right here. Okay, it's these numbers right here. Okay, but what we need to remember is that we need to take the opposite sign of the number that's in parentheses. All right, and that's actually the same for all functions. It's not necessarily going to be parentheses. It could be grouped, but it's going to be grouped together with the x in some way. All right, and we need to take the opposite sign for that. So we're not going to write down 3. I'm going to write down -3, and then the same sign for the y, so it's going to be -5. -3, -5. That is our vertex. The axis is symmetry. That is, as we stated earlier, it's always the same as the x-coordinate of the vertex, so that's -3. Does this parabola have a minimum or a maximum? Notice that negative there. All right, that negative flips our parabola upside down so that it opens down like this, kind of like an upside down U. And so therefore our parabola comes up to a highest point and goes back down forever. All right, so this has a maximum. And that maximum value is always going to be the same as the y-coordinate of the vertex. So this parabola is going to go as high as -5. It's going to have a maximum at -5. Okay, what is the domain? That's the same for all parabolas. I can write it this way. Negative infinity and positive infinity. All right, x is between negative infinity and positive infinity. Or I could just simply say these are all real numbers. All the real numbers. Okay, and the range. All right, so the range, notice that our parabola goes as high as -5, right? As high as -5. So all our y values need to be lower than that -5. Okay, so and that's exactly what I'm going to write. Our y values need to be smaller than or equal to -5. Okay, moving on to question number 3. This is in standard form. Standard form is written with the highest exponent to the left and then decreasing on the exponents going to the right. So this does not tell us the vertex. You can't just like look at it and see the vertex. So we have to find the vertex, and the way that we do that is by this simple formula. The x-coordinate of the vertex is equal to -b over 2a. -b over 2a. So what are our a and b values? Well, that's the first 3 questions here. Right? There's our a value. And here it equals -1. Here's our b value. Here it equals to -2. Make sure and include the sign with those values. No x's, just the number. Our c value is equal to 8. We don't need it for our vertex, but we will need it later on. Okay, so the a value is -1, the b value is -2, and the c value is 8. The c value is 8. So, the vertex we were finding, and that is -b over 2a, and we said b was -2, so we'll put that in place of b, and a is -1, so we'll put that in place of a, and we see that x is equal to 2 over -2. X is equal to -1. All right, so how do we find a y? If we know the x, how do we find a y? Well, that's why they give us the equation. Here it's in function form, right? That's the same as the y. F of x is the same thing as y. And it tells us y equals that equation. So in order to find the y, we need to just plug that back into the equation. So I'm going to plug this back in using parentheses. I'll go negative parentheses squared minus 2 parentheses plus 8. Everywhere there's a letter, right? I just put a set of parentheses, and then in those parentheses, I'm going to put what I am substituting in, the -1. I'm substituting for x. I'm substituting -1 for x. You can just plug this into your calculator, or we could calculate it by hand. So -1 times -1 is 1, plus I still have that negative out front. So there is -1 minus 2 times -1. So that make a plus 2 plus 8. Which is going to give me positive 9. All right, so my y is equal to 9. My vertex is -1, comma 9. Okay, so in the next question it says, write the equation in vertex form. Vertex form looks like this: y equals a x minus h plus k. X minus h plus k. So the a value is the same in standard form as in vertex form, right? It's still the a value, and we already found the a value to be -1. So we can write -1 or just negative, all right, and then put our parentheses. Our vertex was at -1, right? And so if I'm plugging in -1 for the h, right, because this is h comma k, right? That's negative 1, which gives us a positive 1. Or if you think about it, what I said earlier, in vertex form, we always take the opposite sign of what is in parentheses, all right? So we're going to say, we're not going to put in a -1 here. We're going to put in a +1. Don't forget your square. And then we'll use the same sign on the outside of the parentheses. So that was a +9. I'll write a +9. What are the coordinates of the y-intercept? Well, a y-intercept always has an x-coordinate of 0. You think about it. You don't go left or right any. You just go up or down, right? From the origin, you don't go left or right any. If you just go up and down, you're right along the y-axis, right? So the x is always 0. And so we think, okay, well, if I know the x, how do I find the y? You plug it back into the equation. If we plug in 0 for x's, right, look what that does. 0 squared gives us, the negative out front would give us -0. It doesn't matter, it's negative or positive. -2 times 0, right, and 0, so that's that. All this ends up to be 0 plus 8. That c value is our y-intercept. Okay, and what are the coordinates of the two x-intercepts? Well, x-intercepts are the same things as zeros or solutions or roots. Or which one did I miss? Zeros, solutions, roots, or x-intercepts. So, okay, then that's the one we need to find here. So this equation looks pretty easy to factor. It looks like something we could factor. If you have a negative out front like we do here, all right, always factor that out. Like a GCF, and we go negative x squared plus 2x minus 8. Okay, and can we factor that? This is a trinomial now where a is 1, so I'm looking for something that multiplies up to be -8 and adds up to be a +2. What multiplies up to be 8? 1 times 8, 2 times 4, and that is it. I can get that 2 and that 4 to equal a +2 if one of them is negative, which is what I need. Let's make that 4 positive and the 2 negative. I need one of these two numbers here to be negative because we have a -8, right? And you have to multiply a positive times a negative in order to get a negative number, all right? So, and then I choose, okay, which one am I going to make positive? Which one am I going to make negative? Well, notice also the middle number is more positive than negative, so the bigger number here is going to have to be positive and the smaller number negative. Okay, so x-intercepts are the same thing as zeros. If I set this equal to 0, it is the same thing as the x-intercepts. And we use our zero product property to find what values of x makes this a true statement. What values of x? If this factor right here was equal to 0, that would be this 0 times whatever this is, and that would equal 0. 0 times anything is 0. Or if this factor over here equaled 0, we would get the same thing, right? This over here would be 0 times whatever that is, and that would equal 0. So, what values of x make those factors 0? And the answer is, if I just subtract 4 from each side of the equation, I get negative x equals -4. And here on the second one, if I add 2 to each side of the equation, I get x equals 2. All right, so those are my two x-intercepts, right? On x-intercepts, the y-coordinate is always 0, right? And that is why I set the y equal to 0, and I was solving for different values of x. So one of the x-intercepts is -4, 0, and the other x-intercept is 2, 0. All right, in the next review video, we'll go over graphing in given different forms of a quadratic function.